Thank you for coming. This is a hobby to a certain extent. And also one thing I always mention in the beginning, this is really not a presentation. It's supposed to be more of a discussion and a brainstorming. So I'm hoping that you'll interrupt me when you feel like it, or at least when I say certain things that you don't quite resonate with, bring them up at the end of the discussion. One of the premises of this talk is that none of us really know what the answer is. We have a challenge in front of us, and we don't really know exactly how we are going to solve that. And we should not underestimate the importance of trying to rebalance the humanity and environment equation as we approach 21st century. And I'll show you a set of numbers, and hopefully those will resonate and those will bring to the front that it is really a different world. The world has changed quite a bit in the last century. Let's start with the population, and this talk is meant to look at this problem from the side of the human needs, humanity, and not so much about the technology. Technology will have to fit into it, but I think quite often we make the mistake to put the technology first and then try to fit the rest of it around the technology that we seem to love. I really think the discussion has to go the other way around. We got to look at where we are as humanity, as what we need to do with our civilization, how we are going to sustain it, and then hopefully we'll find the right technology solutions to fit into that. Now, this is the curve of the human population. Many of you have probably seen it before. We have recently exceeded 7 billion people. We are probably, well, not everybody in this room, but my generation is probably the very first generation where we have seen a tripling of our world population in our generation. Now, the expectation is going to slow. The best estimates is that by the middle of the 21st century, we are going to approach or slightly exceed 10 billion people. And after that, it will continue to grow slowly. Now, there's uncertainties in there, and a big chunk of the uncertainty is going to depend on the type of choices we make and how the environment and the humanity gets back in balance again. Now, the population growth really, for a long time, the population remained less than 1 billion people on Earth. And it stayed stable for a very long time. Start growing after the first industrial revolution. It is the first time we really start using energy in very large quantities to help our civilization. It was originally coal that fueled the first industrial revolution, and the steam engine that basically helped convert that coal energy to useful energy for humans. Then came the second industrial revolution in the early 1900s. That's when we start using other types of fossil fuels, especially oil and gas, in large quantities. That is when we learned how to deliver electricity to industrial places, commercial places, to our homes, to our televisions. And right after that, the population started growing. The living conditions improved, and the population started growing considerably. Now, since 1950, again, that represents my generation, the population grew by about threefold. In the meantime, our consumption of energy grew by fivefold. And our economy, our economic output has grown sevenfold. So recently, we were able to, in the last 3 decades, we were able to cut the poverty in half in the world. The literacy rate is growing very rapidly, and it is, and we have made a lot of advances in terms of healthcare solutions. So people are living longer, happier lives. Not everybody, but a larger fraction of the population today than in the beginning of the 19th century. Now, what we are projecting is that by the time we hit 10 billion people on Earth, our economic output will probably grow by another threefold. That's roughly 3.5% to 4% growth per year globally. And our energy consumption is going to grow by another threefold. And that's where now we need to balance this curve that we have here with population, that economic output, and our consumption of energy. Now, energy is needed for many things. When we are balancing the equation, it's not all about people having access to televisions and our cell phones and our microwave ovens and all that. We still have problems with food shortage in the world. Today we have it. With 10 billion people, we are going to have it even more. 1 out of 10 people is undernourished today. It's going to get worse. We have 7 million people dying every year. Fortunately, not in countries like ours, not in the United States, not in England anymore, but in a large fraction of the population globally, 7 million people are dying from air pollution. We know by 2025, we are going to have a serious shortage for access to clean water. Water that makes 70% of our globe that we take for granted today. There is a large fraction of the population today, they don't have access to it. And that's going to get worse. And health services. Half of the population today in the world is basically lacking access to health services. And that's going to change. It has to change. So that gives you another reason why we need to start worrying about how we are going to rebalance that. Achieving a sustainable balance between humanity and environment. That's not a new debate. And the analogy that I use for this is the Greek mythology. But if you look at the mythology all the way back to mythological times, you look at the Chinese mythology, the Indian mythology, you'll find the same equivalent dilemma that even back then people were worrying about. In the Greek mythology, Gaia created the environment that we live in, and created Earth and the atmosphere and the oceans and the universe. And Gaia in the Greek mythology is Mother Earth, so owns Earth, but did not create humans. Humans came later on, and a second descendant of Gaia, Prometheus, created humans out of clay, but realized that the humans are not going to be able to survive in that environment with the gods that they had at the time, who were quite nasty. And that's another reason why I like the Greek mythology. Things are not always black and white in the Greek mythology, and gods can be very generous. At the same time, they can be very nasty as well. So what Prometheus did when he created man out of clay, he also gave them the fire, which until then only belonged to gods, and the technological know-how for them to survive. So that created basically a fairly balanced, until, as I showed you in the previous picture, until the beginning of the 19th century, it created a fairly balanced picture between environment and humanity. At that time, technology was used primarily to favor humanity. It was for their survival on Earth, and they used technology, they survived, they flourished, they maintained the balance, and it was not a threat to the environment. However, today, the picture is quite different. Now, we are still using a lot of technology, a lot more than what we used back in the mythological times, of course. But it is causing an imbalance. The technology is basically tilting the balance too much in favor of our, what we refer to our civilization today, and to the detriment of the environment. And of course, the big issue today that we are dealing with falls under the heading of climate change or global warming, whatever you want to call it. And that is one issue. I think it is very important for us to really start taking that seriously and tackling that issue as we move forward. However, my contention has always been, and will continue to be, that that is one indication of what's happening. And if we only focused on climate change, and if we don't pay attention to the rest of that equation and all the other parameters that go into that equation, and a few decades from today, we are going to regret it, and we are going to face another crisis. So this is our opportunity to look at the whole picture, take climate change seriously, and we certainly have the tools to resolve it, but at the same time address the remaining of the equation. Today, we are losing forest at an unprecedented rate. Now, in 1 minute, the deforestation in the world is equivalent to about 27 football fields worth of trees in 1 minute. By the time I complete this, one of my slides, basically close to 100 football fields worth of forest disappears from Earth. Our oceans are changing their chemistry. So climate change is one, but there is a lot of other things that we really need to start worrying about rebalancing. Now, the only way to do that, the traditional environmentalist community that I have argued with for, well, as long as my career, I guess, for the last 3 or 4 decades, is that technology was our enemy. Technology was causing all these problems, and if we were to abandon that, and we would probably have a happier life. I don't think that's true. However, I think the way we use technology is going to be different as we move forward. Now the technology has to be the tool to balance the environment with the humanity, not just a tool for civilization to grow at the expense of environment. So the type of technology choices that we have to make as we move forward is going to be a little different than the type of technologies that we chose in the early phases when we got too excited with the first industrial revolution and the second industrial revolution of just advancing civilization and hoping that the environment will come along and adjust itself. So as we move forward, we gotta start making some tough decisions, and we gotta start looking at this problem holistically. And when I say we, I certainly, in this debate, I certainly represent the technology piece of this equation. I'm a technologist, I'm a nuclear engineer, but when I say we, I don't mean just the technology, a few Einsteins of the world are going to come together and solve this problem. We have to solve it as a society. Everybody, all the stakeholders need to be at the table. This needs to be a debate, and it's not just either the technologists or the lawyers who are going to solve this problem. It's a political issue. It's a social issue. When we discuss about the values, I'll bring some of that up. It is certainly an issue that almost all of us worry about from one angle or another. It's an issue for the mothers who are worried about the future of their kids. It's an issue for the anxious fathers. So it is a society problem. But when we are debating that, we need to set some ground rules for that debate. Now, the very first one that I always bring up is we have to follow the laws of nature. And by that, I mean is that any kind of a energy source that we use today or we are going to use in the future is going to have an impact on the environment. There is no silver bullet. That's a debate that I have a lot with my colleagues from the renewable side. We don't create energy. Energy is in the nature. What the humans do is harvest that energy, concentrate it, and transport it to where it is needed. So by definition, you are intruding into the environment in doing that process. Therefore, any kind of an activity along those lines is going to have an impact on the environment, and we have to accept that. Based on our values, certain impacts we can accept, certain impacts we may not, we choose not to accept, that's okay. But we are not going to be able to come up with a solution where it says, oh, we'll have plenty of energy, but we are not going to impact anything at all. Everything else is going to be the same. So that's not true. It's not going to happen, so we need to accept that. And we need to make our decisions based on the risk that we are willing to take for the different choices that we make. Again, that's a message to my older environmentalist friends that the only way we are going to solve this problem is by technology. Abandoning technology is no longer an option. We are not going to go back to the 1700s, 1800s. Humanity is not going to go back to pre-industrial revolution. So we need to embrace technology, but we need to use it wisely. And starting with the premise that humans are bad, they'll always be selfish, they'll never solve this problem, is not going to get us anywhere either. That debate is fruitless. We have to assume that the human conscience and ingenuity is what we need to solve this problem. we have a lot of debates. We see a lot of movies, we see a lot of predictions in terms of doom and gloom that our past is taking us towards. That's great. It makes good entertainment. Predicting all the doom and gloom gets people attention. That's great. But I think we are at a point now, is instead of predicting the doom and gloom, we gotta start predicting on the bright future that we can achieve and start working on those solutions. So arguing about all the mistakes we made in the past, and we certainly did, and we will probably continue to make a few more mistakes, but arguing about the past at this point is not gonna get us anywhere. We have to look forward, and we have to start accepting the solutions that we can come up with. And the problems that we are facing today, with 7+ billion people today and 10 billion people soon to come, the problems are no longer local. They are no longer regional. That we are not isolated from them. There's no community that's isolated. Climate change is a very good example of that. We all share the same atmosphere, therefore any bad effects that may come out of the climate change is going to affect us all. Oceans are another example of that. The further the acidity of the oceans keep increasing, it's going to affect United States as well as the countries in Southeast Asia. I think it was our President Ronald Reagan who said that the humanity is its best when we have a common enemy and a common challenge. And I think the environment is giving us that today. It is no longer just affecting one set of community. It is affecting us all. And that's why we need to find a solution altogether. And the most important one, especially that is at my end, those of us who are in love with our own technologies, is we always start any kind of a debate and a kind of a solution by basically talking about the wonders of our technology. That's if everybody just agreed to our technology and used our technology, how the world would be a much better place. Well, I don't think that is true. I think we are going to need all the tools that we have. One technology is not going to solve the problem. So we got to start the debate away from this technology tribalism and start understanding each other and start finding the goods in everything and criticize the parts that are not working very well. So this has to be a value-based argument, not technology-based argument, not economics-based argument. It has to be based on our values. When we were discussing this, we came up with a number of values that people resonate with. And let's see how we map those things into that. And one value that we all, especially when it comes down to energy sources, performance. How well do they perform? How do we measure that? How do we value that? The most common way we value that is cost. We want it to be affordable. We want people to have access to it and be able to afford it. A very expensive energy source is not going to do much for humanity, or is not going to do much in advancing our civilization, our economy. So cost is important. But unfortunately, it can also be misused. It is very difficult, especially for the type of events that can affect, that can have global effects, things that can have environmental impact. It is very difficult to evaluate the true cost of any one of those technologies. Now, there are three types of costs that go into when we are measuring the electricity that gets delivered to our houses. One is which technology are we using to produce that electricity? And obviously, from one technology to another, there is some differences depending upon how you're mining your resources and how you convert those resources to electricity. So there's a technological cost, and that is fairly quantifiable. We can quantify that to a certain extent. Not exactly, but we can quantify. Then there is the delivery cost on how we get that energy from where it's generated to where you need it. And that's common to all of them. So the cost of that is roughly the same for any of them. But a big part of the energy cost is the societal cost. And that is where things become very blurry. How do you value air pollution? How do you convert air pollution back into the energy cost equation? How do you value acid rain? How do you factor that back into the energy cost equation? So if we focus too much on cost, unfortunately, A, I don't think we'll always get the right results. And B, I think we are also basically encouraging the technology tribalists to start cheating. And we got to avoid that. So cost is one thing, we need to look at it, but it cannot be the only determining factor. Reliability is very important. Now, you want to have the energy when you need it, where you need it, and it needs to be, especially when you start talking about food production and food preservation and healthcare type of issues. It's having a lot of energy at one point and then not having any energy at all at certain points, especially if that's unpredictable, is not necessarily a very good thing. Overall, you may have a lot of energy, but if you don't have it when you need it, the cost of that and the results of that is not very good. And one of the things that you always worry about, and that has happened to us a number of times in our modern society, is what happens when you need the energy the most and you don't have it? How does that translate into the cost equation? You probably need a lot of energy during a hurricane, but you don't have any of it. Or you have very little of it. And what's the environmental impact of our choices? Again, that brings up the fossil fuels are abundant. We have mastered that technology. We use a lot of it, and we are going to continue. And don't get me wrong, we are going to continue. I think anybody is lying if they say that, yeah, we are going to decarbonize the world in the next few decades. We are going to continue to use a lot of fossil fuel as we move forward. But we need to start looking at other aspects of the environmental impact as well. Carbon emissions is one thing. And as an example, I show this. This is the land use. Again, you can find a different set of examples. This is not supposed to be an all-comprehensive. Again, this is a debate. This is a brainstorming. So this is one example I use. Let's look at land use. Land is important in many parts of the world. Not everywhere. There are places where we have plenty of land. There are places where we don't have enough. So this compares the different energy sources with respect to their land use. It is a purposefully exaggerated plot. It goes through the renewables, coal, and here's a spec for nuclear. And if you basically put those side by side, it does give you an idea of if land is an important value for you, that preserving land for other purposes than energy production, this will be the comparison. Nuclear is a spec. Obviously, traditional biofuel is a big, huge land consumer. And renewables are somewhere in the middle. Now, one of the things I have to say in here is that this renewable plots in here, it's just for order of magnitude comparative purposes. These numbers can change. Depending upon how you calculate it, obviously with solar, the altitude, where you are on Earth, and the solar density and all that stuff, it's going to change those numbers slightly. With wind aggregates will tell you that the wind turbine doesn't take a lot of room and you don't really need to account for the space you have to put in between the wind turbines, because you can always grow some cucumbers in that area. And those who are not wind advocates will tell you that, no, you're not going to grow cucumbers in that area because you have to pour concrete for the basement in that area. So those numbers can change, but it's just for comparison. So that's one value. I think as we move forward with 10 billion people in the world, equity and fairness is going to be a very important debate. Now, concerned mothers are always worried about the intergenerational equity, and they should. We should not have our children and our grandchildren paying for our choices today, because those choices are convenient for us today. They improve our quality of life. They make us live much better. But someplace down the road, then they're going to have to pay the price for it. To a certain extent, our generation is doing that with the climate change, depending upon how scary you find climate change. But climate change did not occur in our generation. Climate change started with the first industrial revolution. That's the direction we took. And now today we are paying for a lot of that stuff. So intergenerational equity is important, and the choices that we make today is important to many people, so that our children and grandchildren will have access to the same quality of life we have today. At the same time, they have access to the same quality of environment that we have today. So we need to preserve that. But intergenerational equity is equally as important. With 10 billion people, today, electricity is the most advanced form of energy that we use. That is the one that has the biggest impact on our quality of life. 90% of the electricity that we consume today in the world is used by only half the population. The remaining half of the population on Earth live with the 10% of the total electricity that we generate. There's a graphic that basically shows it in a slightly different format in terms of how advanced the society is, and it uses the transportation mechanism to illustrate their advancement in civilization. 1 billion people don't have any access to transportation. They still walk. Everywhere they go, they still walk. And that's the same 1 billion people out of 7 today that have no access to electricity. Many of them don't even know the concept of electricity. The 3 billion people have access to some primitive transportation. It is still heavily dependent on hydrocarbons as the energy source, in other words, mussels. They don't have a very good life, but they're a little bit better off than those who don't have any access to electricity at all. And the top 1 billion people, fraction of the world, it's enjoying all the benefits of our civilization. We need to get these numbers rebalanced also, because at some point with 10 billion people, this kind of inequality is going to start creating a lot of conflicts. And those conflicts are going to be serious. And I don't necessarily mean always wars and killing each other, but there is going to be mass migrations, and we are seeing that today. There is going to be famine in certain parts of the world that the rest of us will have to go do something about, or so. That imbalance is going to have to be solved, and our technologies will have to help us to get there. And the last one of the values is abundance. And abundance, again, depends on where you are, how much access you have to fuel, for your energy source. Carbon in general, but the fossil, carbon specifically, but the fossil fuels in general are fairly abundant, and they'll remain abundant for a long time, and people have access to it. And also people have access to technologies on how to use that kind of fuel to convert to useful energy. So it's going to get used, which for those of us who worry about climate change and the carbon emissions, that means one of the technologies that we really have to pay attention to in the very near future and implement it as quickly as we can is referred to as either carbon capture or sequestration or carbon capture and reuse. So we gotta do, we cannot keep dumping all that stuff wherever we can for convenience. We gotta do something about that. And we have the technologies to do it. So, but another part of abundance is technology. Just because a certain source of energy is abundant, coal, it doesn't mean that's the only thing that we need to use. Other sources may be less abundant, but they may be much more efficient. Nuclear falls in that category. Now, uranium is also very abundant on Earth, not as abundant as coal, but there is plenty of uranium. Now, the energy density of uranium is 1 million times higher than coal. And this graphic over here, what you're watching, illustrates that if you can take a uranium the size of an apple, with that uranium, with today's technologies that we are using today, the nuclear reactors that we have today to convert that to electricity, we can power 65 homes for a year with just the size of an apple uranium. Now, the equivalent of that, if you were to take the coal, a lump of coal the size of an apple, you will power one of these light bulbs up there for a couple of hours. That's all you get. Now, there is also designs out there that if you were to implement today, that 65 homes can easily become 400 homes with today's know-how. That's where the advanced reactors come into play. Now, the theoretical limit for uranium if I can if I can fission every atom in that apple-sized uranium and convert all that to electricity, I can, with the same size of apple, I can power 4,000 homes for a year. Now, again, this shows you the abundance is also very much related to technology in terms of how we use our resources. And access to that technology is important for areas where we need abundant energy. So, at the end of this, really, at least my conclusion was that there's no silver bullet. If we are going to rebalance this equation, we are going to have to look at a spectrum of technologies, but we need to integrate them together properly. Now, many of us have heard through multiple administrations for different, with different political views, that the solution is all of the above, that we need to use all of them, and that is true. But it is very important to understand what we mean by all of the above. To some people, all of the above means, well, whatever is, we are not going to make a choice. Whatever is convenient for that day, that's what we are going to use, or for that year, or for that area, for that region. That's not what I mean by all of the above. What I mean by all of the above is we are going to look at the entire spectrum of those technologies, but integrate them and choreograph them very carefully in such a way that one becomes a complement, supplement to the other. At the end of the day, when we put them together, that the whole is bigger than the sum of the pieces. Combining solar, wind, and nuclear becomes much more powerful than just using solar by itself and adding someplace else a nuclear power to it. If you can operate them in tandem, that's when it becomes very powerful. And that reminds me of a very famous painting that I adored when I was young. And it was one of those in the early part of when the artistic revolution was taking place, at the same time as, coincidentally, as the scientific revolution, early part of the 20th century. A lot of people were painting, focusing on painting dancers. And they were famous painters who drew real nice dancers. But one guy decided that, no, the issue is not the dancers. I want to paint the dance. And that was perhaps one of the most controversial paintings of the early 20th century by Matisse. He painted the dance. A lot of people looked at it and they thought it was a very primitive way of painting compared to everybody else. But it became one of the most famous paintings of that early century. And again, the idea was that his focus was on synchronizing and harmonizing the colors and the motion, and not so much on what every individual dancer is doing. And to me, the energy technologies and the integration of the energy technologies is a very good analog to that. Instead of paying attention to just our favorite technology, we're going to pay attention to all the other technologies that can supplement it. And that was my last slide, but I certainly want to express my special thanks to who have helped me over the years to get to where I am with respect to this discussion, to this brainstorming. A good friend of mine, Kirsty Gogan from United Kingdom. She is an environmentalist. She's one of those environmentalists that I love because she's a pro-nuclear environmentalist. And we've been discussing this issue with her for many years. And she is looking at the problem the right way. And she runs a nonprofit organization called Energy for Humanity over there. I had a lot of help from Potomac Communications in Washington with respect to graphics and messaging. And certainly, last but not the least, the Idaho National Laboratory, our communication folks who have over here, Courtney, Caitlin, Nicole, they helped me quite a bit. And my lab director helped me because he pays for the time that I spent on this. So thank you.